Okay, hello everyone. Today I'm going to talk about how to integrate the Fuego automated testing tool in your CI loop. I will show you how to integrate with different components. I want to first thank Linaro for inviting me. It's been a great week, and I've been able to meet amazing people like Naresh, Chi, and also Dan Rue and Mar. So it was really a great experience for me. So I will start with a little background. So the open source testing field is now really very. There are many tools in the field, and this is great. But we noticed there was a little bit of fragmentation, so we thought we should be able to share at least some of the efforts. So because of that, we decided, team decided to create an automated testing summit in Scotland, and that was great because I always wanted to go to Scotland. When I think of Scotland, I always think of Braveheart with Wallace. So in this case, we had Tim Wallace bird. Oh, you cannot see here very well because of the light. I put you a white and blue mask. And also Kevin Hillman, the developer and leader of kernel CI. So you have here all of the minutes and what we did. Two of the interesting things that came out were the test glossary, so that we can have the same vocabulary when we talk to each other, and then a test stack survey, so that we can know what each tool does in each category. And at the end of the meeting, there was something that I thought was interesting. It was said by Michal Simek. It was, let's try to try each other's testing tools and figure out how to collaborate. So inspired by that, I decided to try to integrate Fuego with different tools that I hadn't tried before. In the next chapter, I'm going to introduce how to use Fuego as a black box and how to integrate it into different CI loops. So first of all, Fuego can work in a host and target configuration. So basically, you have to create a board file where you input the IP address of your board, the login username, the password, or maybe an SSH key, and the transport, which can be, for example, SSH, but also there are other like serial or different ones, and the toolchain in case you want to build the tests, which is the most common case. Now in the next branch, I forgot to say this. The materials that I'm going to show here are mostly what I call conference-driven development. So most of it was finished just a few hours, including the slides. And this is in the next branch. So in the next release of Fuego will be there. It was mainly triggered by the need of Chase, so having a Docker container that could be run natively, and I think this is a great idea. So basically, you can have now Fuego installed natively on Debian or on Ubuntu or anything that runs Python. So these are the two main configurations. Okay. So first of all, I want to just do a short demo of how to use the Fuego command line, which was the FTC here. Now Fuego has auto-completion, so it's easier to use the command line. You can see here what you can do. You can list your boards, list your tests, add, for example, run tests, remove jobs, and stuff like that. Let's just list the boards that I have. Okay, so I can, for example, request the IP address of one of the boards. So now I'm running a virtual machine, a QEMU virtual machine on this laptop. Okay, so this is the IP address of the virtual machine, which is like a board I'm gonna connect. So now I want to run a test. I'm gonna run just the hello world throughout this presentation.
I just hold the microphone for you?
That would be great.
Okay, I'll just be your microphone holder.
Thank you. Okay, so I'm gonna run test. The board will be the virtual machine and functional hello world. Hey. So now we see that Fuego has different phases. First is doing a pretest, checking that we have connection. It deploys the hello world program, and the test result is success. Okay. Now we can have different parameters for this software, this test. For example, we can use the list specs for functional hello world. And we'll see we have here a hello fail, which is going to make the test fail. These specs are just like parameters that are well known and that you can then modify, but it's like what static trace points are in the kernel. Like they have some know-how. This is interesting. This is an interesting set of parameters that you can run. So if I run now the test, but using the spec hello fail, now it should fail. So we go through the same phases. We run, and yeah, the test failed. All right. Now, one of the things you need to know is that if it fails, the return parameter is going to be 1. And if it doesn't, it will return 0. And you can also see what test cases inside the test fail and so on. And we can generate a report with the Gen report tool. This is a tool that allows generating reports in PDF format, Excel format, CSV format, so that you can just handle this as a report to your customer, for example. And it works like a database. You have a kind of SQL sentences where you can select which tests in particular you want to show in your report by using this where and conditions. Okay. So okay. Just for a little bit. I will come.
Okay. Just holler if you need help.
Okay. Okay. So the first integration I'm going to show is just Jenkins with Fuego, and this is the integration that comes by default. And basically, what it does is, from Jenkins, we call this FTC run test that you just called from the command line. But in the next branch, I added, so this is the default when you install the Fuego container, but as it says here, if you put this --no Jenkins, then you will install Fuego without Jenkins, okay? So in case you don't need Jenkins, you can separate it, all right? And what's the role of Jenkins in Fuego? It could work as a web server interface with user accounts and stuff like that. It also makes sure that tests only run one at a time on each board. It displays results like the logs, plots, tables. It can be used as a test trigger, like test it periodically, or when you push to some repository. You can use it for notifications, send emails, and it has another bunch of plugins. And also it can be used for board scheduling using Jenkins labels. So I'm gonna do a small demo with Fuego Jenkins. now we see here is the. Hello? Hello? Okay, so this is the Jenkins interface. I'm just going to add a node. Hey. Hello, hello, hello? Oh. So now I added a board, and you can see it here. VM is a virtual machine. And then I can just add jobs to Jenkins. So I'm going to do add. Okay, I can list the tests that I have. I have a lot of them. FTC add job -b, the board is the VM, and I will add the functional hello world. And again, I'm going to do the same, but for the hello fail spec. I will add it. And I'm going to add another one, which is a benchmark that I stone. And this benchmark has several specifications. One is this one. One of them is going to fail, and the other is going to be okay. And now I can trigger the build from the command line. So I'm going to trigger part of the jobs from the command line. I build jobs. I will use a wildcard to select the jobs. So asterisk here, then functional hello world. Okay. So now if we go back to the interface, we have this job here in the queue. Sometimes it takes time to. Oops. Oh. It seems that this failed. I don't know why. That's it.
Yeah, I know why.
What?
There's a bug.
No, but okay, I will run another one.
Yeah, that's fine. Run it again. It'll succeed this time.
Okay.
You only passed it as a hello fail.
We're still shaking the bugs out of the command line separation.
Yeah. Maybe it could be that.
It reused the build ID.
Right. Okay, yes, right. You're right. So I ran a previous job before from the command line, and Jenkins didn't notice because I ran it from the command line. That's why. And now he thinks it failed, but it's not true.
Because the logs go to the same place or something?
Yeah, exactly, yeah.
Every name has the build ID in it, and so I thought we had fixed that bug. This is our next branch to me.
Well, this is usually what happens when you do demos. Okay, I'm gonna leave this running. But yeah, what I wanted to say here is, if you go here and you click on configure, you will notice how this is working. So first of all, here there is a label expression that says VM. So this is, states which boards we can run this test on. Then we have here like build triggers that we could use, like build periodically and stuff like that. And here is where we actually call Fuego. And as you see, all we are doing is to call the FTC command here. Okay. So let's see. Oh.
How does Fuego create new Jenkins jobs? Is that GGB based?
We're using a Python module.
Jenkins module.
And we construct the XML and push it out.
Okay.
There's another one up there. Oh, okay, sorry. So Fuego constructs the job XML and sends it to the Jenkins server using the Python Jenkins module.
I see this.
It's sensitive to the Jenkins version because the Jenkins guys are crazy. They modify their formats all the time.
Yeah. In Linaro, we're using the GBB from OpenStack project. And so that we can use YAML file to describe the project aspects. So it's probably a different way. I just wondering. Thanks.
Thank you. Okay, so here in the dry stone, which is a benchmark, we can see that we can have a user interface with plotting. And in the case of Hello World, what we have is charts instead of plotting. Oh, now it's working. So this kind of, yeah. So we can click here why it failed and why it passed. So this is the Jenkins integration, okay? I need to speed up a little bit because I have a lot of contents. Okay, the next step is K-Test. So K-Test is a tool that allows building the Linux kernel, deploying it into the target port, execute a test, and then this test can be custom. For example, it could be any Fuego test. For example, we can run LTP for each patch that for a set of patches using patch check, or we can do a bisect to know when one of the LTP tests started failing. Okay, and I'm gonna make also a demo for that. So here, K-Test. I'm using a wrapper for K-Test. It's called ELKDAT, which basically prepares a virtual machine for you and reboots it and stuff like that. So it's already up. I'm going to check the configuration. And as you see, this is the IP, the SSH username. It has a private key to access through the SSH, which is required by K-Test. For this demo, I added this build no clean so it doesn't have to recompile the kernel from scratch, because otherwise it would take a long time. And basically, what I did is to put this this IP, this username, and this private key in the board file of Fuego. And now I prepare a test. So I go to examples, test, Fuego hello. As you see here, all I'm doing is to execute FTC from the Fuego container to run the hello world on the virtual machine. Okay, so if I do test, examples, test, Fuego hello, K-Test is gonna rebuild the kernel. And once it rebuilds the kernel, it will run the hello world test, and if it is successful, then it will say success, and otherwise it will say that the patch, for example, failed. Okay. Okay, I need to go ahead because I have more things to say. So the third integration I wanted to show is how to integrate GitLab with Fuego. Basically, you have a source code repository in GitLab, which is, as you know, open source, but also it's a hosted service. And whenever you do a git push, then GitLab will spawn a Docker or a Docker machine for free. And this Docker machine contains a GitLab runner, which basically will translate this YAML file into commands, and you will run those commands. Okay. By default, it's a Docker, but you could also use your own virtual machine or your own board, and in that case, you would be able to test the kernel as well. So I'm going to make a demo about GitLab. But before that, let's check if K-Test was successful. Yeah, as you see here, the Fuego Hello World was successful. There is another one with failed, so I'm going to leave it running, and I'm going to go to GitLab. So basically, this is the GitLab repository. There are better ways to do it, but this one works for now. So I have here a zlib, which is a library for compressing stuff, right? And then I put a test for it here, functional zlib. Normally you would have it in a different repository, like here, not here, but Fuego zlib. But the thing is that if you have triggers between two repositories, then you need to have a premium account to trigger from one to the other. So instead of that, I put them together. And the GitLab YAML file looks like this. So first of all, I download a Docker image that I prepared, which has Fuego inside. Then I just move the latest zlib to the functional zlib2 folder, and I put it into the test folder. This actually can be done in a different way by installing a test package, but in this case I'm doing manually. And then I run the ftc run test -b local. Local means in the native machine, and I run this zlib program. Also, as an extra, the library that was built can be saved as an artifact so that you can download it and use it for deploying it into your environment. Okay, so the demo this time is going to consist on introducing a bug and see if it goes from pass to failure. So I'm gonna go. By the way, let's check the previous log. When I say Fuego Hello fail, it actually failed, and so it looks like it is working. Okay. So let me go to the GitLab. Here I have the zlib library, and I'm going to introduce a bug, which I will do just with a revert. So what I did is to put just Fuego bug here, and then I will push. And when I do that, GitLab will wait for resources and run the YAML file in a container. So now it's running it. We can click here. We can see here is the test pipeline, which is just one stage, but it could be much more complex, having several stages like build, deploy, and stuff like that. And if we click here, we can see what's going on. At the moment, it's pulling the Docker image. We will go back a little later. I'm going to continue then with the presentation. Any questions so far? Okay.
You need to twist the mic again.
Oh.
It's like
Hello? Okay, this is much better. Okay. So, for example, this could be used to build test binaries that could be downloaded to Lava, for example. You just put each test in a different repository, and whenever the test code is updated, you rebuild the test binaries, and then you can just download them from Lava. And you can do the same for any other software that you want to test. So it could be used as a test tool, as a build tool as well. Okay, so next I want to explain how to use together Fuego and Lava. One of the possibilities is to use an SSH hacking session. which is basically a method where Lava does the provisioning. It turns on the board, it prepares the file system and the kernel, and it creates an SSH connection. And once you have an SSH connection, then you can go and start Fuego and run the tests on the board. So to do that, you have two variables, setup link and teardown link, where you have assigned two scripts. And then basically what this script does is to prepare a Lava job file, a YAML file from a template with an auto login and stuff like that, and it submits the job. It polls for boot to complete, and finally it checks that SSH is working, and at that moment it hands control over to Fuego. So this one is explained here, and I'm not going to do a demo. There is another method to combine Fuego and Lava. This was implemented by Chase, who is here. And this is actually a great method because what it does is it starts a Fuego container on the Lava slave, and in this configuration, Fuego can work as a host target as usual. So most of the tests should work with this. So if I click on this address, you can see how he created the YAML files. So basically he is using a feature in Lava called multinode to prepare the Docker and the board. So this is very powerful, but also at the same time it can be a little bit tricky because of the features that he's using. But this is probably one of the best ways we can integrate Fuego with Lava.
May I?
Yeah.
I think this is we did it this way because this is the best option by far we figured out. Actually, wherever it's possible, we are trying to avoid to use the multinode API because it's complicated, typically for the new users. I personally don't encourage a new user to try it. And maybe Daniel will say how to install Fuego without Jenkins and Docker. Once we have that features, it is possible to run single node job in Lava to run Fuego tests.
Yeah, thank you very much. Okay, so going back to GitLab, it seems that this should be already finished. Oh, now we see that it failed, right? So we can check here that it found the Fuego bug. So we just need to reverse that commit and commit again to make it successful. Okay. So it failed, but is what I wanted to show, right? Yet another way to combine Fuego and Lava is using a Docker container that provides Fuego. So in this case, not a Docker container, a file system that contains Fuego. So in this case, what it does is just downloads the file system and exports it to a NFS root file system, and it boots the board. And then we can run any test from Fuego with the -b local. This is especially suited when your Debian when you're using an image that has a generic operating system with packages like Debian. And here I show a few tools that can be used to create these Debian images: ISAR, Meta8, and Devos. In this demo, I'm going to use Devos, but ISAR and Meta8 has some more functionality than Devos. For example, it can customize the file system in different ways. It can compile, rebuild packages, and stuff like that. So instead of using Yocto, which takes a long time to compile, you can just use ISAR or Meta8 to download the Debian binaries, create the compiler, the operating system image, and only rebuild the parts that you need, like U-boot, the kernel, and maybe some packages or something like that. So I'm going to show you how this DevOps configuration looks like, because I think it may be useful for you to understand what the requirements for Fuego are. So I go here, and I go here, metadata. So this is a file system for a Renaissance board, which is now in England. Basically, here I selected Buster, Debian Buster, the latest version. It does a bootstrap. Then I install some packages that are not related with Fuego. It's just some packages from another project. And here I installed the dependencies for Fuego. These are the Python dependencies, as you see here. Oh, can you see? A little bit bigger. So if you install these Python packages, you already can run FTC. Apart from that, we will need the Git, SSH pass, the SSH client, curl, the Lava tool. And then we need to install some SDK. In this case, we are going to run the tests on ARM, but we will install, instead of installing a cross compiler, we will install a native ARM compiler. So GCC, G++, some libraries. This is an SDK, okay? And then some other, like a server, but this is not really necessary. And then I set up a user, the host name, so that it can be recognized by Lava, and a few more things. And I install some links for Fuego. I create the image and I export it as a tarball, okay? So once I have this image, I uploaded it to Amazon with just AWS copy to Amazon. And the next step is to run the Lava job. Okay. So I'm going to show you the Lava job I'm going to run. In this case, it's going to be Linaro DevOps Fuego hello. So this job consists of several steps. First of all, it's going to download the kernel for this board and the image, the DevOps image that I just prepared from AWS, from Amazon, and the DTB, okay? It will download them to the Lava slave. And the Lava slave will extract the tarball and create a NFS root file system. Then it will start turn on the board, and it will wait for the prompt. So here I say wait for CIP login, the username is root, then it will come, a message will come, password, you put the root, and then you will have a prompt like this, and Lava will recognize it through the serial port. And finally, we get here to the test, which is what we want to do. So basically, I wrote an inline definition of the test. This part could be in a separate YAML, but I thought it would be easier to show in just one YAML. And basically, what I'm doing is just to run FTC on the local board and then getting the return value. Apart from that, I'm also, so Fuego, apart from the return value, it returns a run.json, which is a file with all the results for little test cases, test sets and stuff like that, the metadata and stuff like that. So then the next step is to convert this run.json into something that is supported by the Linaro test definitions, which is like a text file. And for this, I'm using Chiche's script, which I renamed to Fuego to Lava. Thank you very much. And then I'm also reusing Linaro test definitions sent to Lava. So I didn't have to do much work for that. And then I check the return value. So I'm going to just send this job now to England, and hopefully the lab in England is working. So for that, there is a nice tool called Lava CLI, which can be installed with pip, for example. And I hope this works. Hey. Oh, it works. So now we can go to the interface. By the way, what I'm using here, this laboratory, is what we use in the CIP project for testing our reference boards. So basically, the Civil Infrastructure project is a Linux Foundation project that tries to contribute to the LTS kernel and the Debian LTS project. And once the LTS the kernel is finished maintenance, we will try to extend it for a few more years, up to 10 years. So we really need this kind of CI loop for regressions, okay? So I will reload this here, and this is my job, and hopefully it's going well. It is downloading the image, the DevOps image, which is about 500 megabytes, so it will take some time. I will go to the next step, and then I will go back to see what the result was. Okay, so far 3 ways of combining Lava and Fuego. Any questions? Okay. Okay, the next is I wanted to combine Fuego with PDU daemon so that we could have a method to turn on and off the boards in a more standardized way. So PDU daemon is really great because it has a lot of drivers for PDU, for different PDUs. Basically, I added 3 commands: power on, power off, and reboot. This is still not merged in the next branch, but we are working on it. Basically, it works by sending a HTTP request to the PDU daemon, and the PDU daemon will take care of the PDU. So it's quite simple. There is no demo for this. The next integration is Fuego and Squad. Maybe you have noticed that Jenkins is it doesn't have a very beautiful interface. It cannot do searches, comparisons between logs. So we found this great tool called Squad, which is made by Linaro. It has a very nice interface, REST interface, so you can just upload all your test results and your artifacts to Squad. And basically what the interface in Fuego is FTC put run, and then using the REST interface it goes to Squad. So Squad's roles here is to visualize all the results, being able to search the results across a history, and especially to compare results across different boards and different kernel versions. I did a presentation about that here, but I'm gonna do also a small demo. But first, let me check if this is finished. Oh, it's still downloading. So I will go ahead with the Squad demo. So I have now Squad running in my local host. Previously, we did some tests, some Hello World tests here in Fuego. So what I'm going to do is I'm going to list my runs first to see what I want to upload. So I do list run -q, list runs -q. Okay. So I have all these runs that I could upload. I'm just going to upload one of them. So it will be FTC put run. And then you put the run ID or the run file. So I'm going to select just one of them, maybe this one. I will put it here and hopefully this will work. Okay, posting to localhost API, my group, my project. And if we go here, well, here is the metadata provided by Fuego. We have 2 tests, one I did before this presentation and the one I did just now. So if I click here, We can see the results. The hello world test case was correctly, was successful. And we have also these attachments, which I don't know where they are now. But they should be somewhere, yeah, here. You can download all the build artifacts that can be relevant to debug why the test was unsuccessful or successful, like the test log and stuff like that. So going back to here, it seems it finishes doing the test. So I'm gonna go back. Basically what we did is we put the board here, then Lava recognized the login prompt. It logging with the root password, and then somewhere here, I think Naris is very good at reading these logs. Somewhere here is FTC, yeah, here is FTC, so we are running the hello world here. So it starts with a build phase, it unpacks this hello test, it compiles it in the native compiler. This is our ARM board. We are running the CIP kernel hello world success, and it was successful. And here is the conversion from Fuego to Lava using Chiche's script, and then sent to Lava here, so that we have these signals which are recognized by Lava from the serial port, and it actually classifies this as a test result. And hopefully, if I click here, is this correct, Naresh? Yeah. Right? Okay, so it's working. Okay, so going back to the presentation. In this next block, I'm going to introduce Fuego more as modules that you can share. So Fuego can be divided in multiple modules, like a command line, the board definition, overlays, pass criteria, dependency system, dynamical variables, specs, charts and plots. So there is a lot of know-how that could be excised from Fuego and ported to different places. The first I want to show is how to combine, for the fourth time, Fuego and Lava by using native definitions. So this basically, the concept of this is basically to extract all Fuego test definitions and add a wrapper for Linaro test definitions. So if I click this link, you can see my repository, which is basically a copy, a fork of the Linaro test definitions, and I added this Fuego here, okay? So this wrapper is basically a shell script which contains the functions and variables that are used by Fuego tests. For example, call if present, put, command, abort job, stuff like that. Assert, define. This is used, log compare. This is used by Fuego tests. So this is like a simplified Fuego. And here is where the phases of Fuego are. Let me increase the size. So here is where the test phases: test build, test deploy, test run. So it's just like a small wrapper. If I go back to the repository, here I have a few test definitions from Fuego that I copied and pasted here. I had to do some small retouches, like converting some details for making it POSIX shell compliant, but most of it is working as it is. Then there is here the Fuego YAML file, which basically in this case has two parameters. One is the skip install if you don't want to install anything on the target, and the test that we are going to run. For example, by default it's hello world. And what this does is just to run the Fuego SH, passing the parameter of test, and then it sends the results to Lava. Okay? So I'm going to submit this job. So I will go here. So now I'm gonna submit the Ethernet tool, I don't know how to pronounce it, Ethernet tool to Lava. I'm gonna show you what this job looks like. Lava CIP core Eth tool. So basically here I'm doing the same as before, but for a different file system that I have. I'm waiting for the login here. And in this case, instead of having an inline test definition, I'm just pulling my test definition from my GitHub account, and I'm selecting what is the test that I want to run, Fuego YML, and what is the test that I want to run in Fuego, and in this case is functional S2. So I'm gonna submit this again to England, and hopefully it still works. Jobs, submit, Lava, zip, core, is tool.yml. Okay, so the request is now queued. We can see if we go to the results page. We can see here how Lava is downloading the file system. This file system is smaller, it's just 27 megabytes because I didn't create it with Debian but with MetaDebian, which is a tool that is something like open embedded but using Debian source code instead of Yocto source code so that you can have long-term support for all packages. So this is booting, and it will take some time. I'm going to go ahead to the next step. Yeah, so this is another integration between Fuego and test runners. So Fuego is very good at wrapping test runners. For example, we have support for auto package test. So all packages in Debian that have auto package tests inside, we can test them. All packages in Yocto Open Embedded that has ptest, that has tests inside, we can also run all of them. Of course, we can run LTP K-shelf tests, and now we can also run Linaro test definitions. So I'm going to show a demo running Linaro test definitions directly from Fuego. Oh, by the way, the previous test, you see here that it passed. Yeah. So here is the F tool. The commands that are run, test pass, it was test failed, was found 0 times, so it was successful. Okay. So now we are going to run Linaro test definitions from Fuego. So to do that, I'm going to open a new shell. Fuego. I think they are here. Yeah. So first of all, I'm going to show you. These are the test definitions. So I have to do automated being set emb, and I'm going to show you that Linaro test definitions are actually great because you can just run them on your local machine like this. So if there is any error or something, you can debug it very quickly. But also, they provide a test runner which can do SSH to a remote machine. And this is the one that I'm using in Fuego. Basically what I'm going to do is I'm going to go to Fuego here, and I'm going to say FTC, run a test, run it in my virtual machine. The name of the test will be functional Linaro. I will use a thing called dynamic parse, which is just like overriding the parameters, the default parameters. And here, okay, I'm going to use a previous one. And here what I selected is, first I will select the smoke test. I select a YAML file that I want to run, okay? So I run this, and this will connect to the virtual machine and run all these smoke tests and give me a result, hopefully. It's taking some time. Could be. Oh, there you are. Okay, so it's now working. We are in the run phase. I don't have much time. Okay, there you are. So here we see that all of the tests, smoke tests, are passing. 1, 2, 3, 4. Okay. So it works. I think this was the latest. Yeah. Okay, so this is the latest demo I'm doing. I have 2 more minutes. I also started creating a Fuego Test parser because I thought that Fuego contains a lot of valuable parsing code. So it would work something like this: iozone, create a iozone log, and then with this Fuego parser, we could parse it and create a JSON file in a standardized format. This standardized format is what Fuego is using, and it's very similar to what Squad is using and kernel CI is using. And I suppose it would be nice to just standardize this, right? My goal was to support any test framework and benchmark that is kind of relevant, famous. And it would also support, apart from this output.json, some other types of formats like XUnit, tab, or whatever, so that we could even convert between formats. But as I started doing it, I started to find a lot of difficulties. For example, depending on the parameters, the test log is completely different, and you have to implement very clever parsers. So it's going to be a big effort. So I think if nobody helps me, I won't do it. But if somebody helps me, I will do it on a best effort basis, because this is a huge task. I need to be careful. So I don't promise anything. Just saying this would be great. If somebody wants a new task, just talk to me. And finally, the conclusions are that Fuego, I show you several ways of combining Fuego with different CI tools. I presented 4 methods to run Fuego on Lava. I presented how to run Linaro tests on Fuego and other packages, the GitLab integration, Jenkins integration, K-test integration, and Squad integration. So thank you very much, and I hope you have now a better idea of what Fuego is and how to integrate it with your tools. Thank you.